Welcome back to day 2. So today we're going to learn what permutations versus combinations means. So here's our warm-up. 16 teams made it to the NBA playoffs. How many possible ways can the first, second, and third place teams be decided? So we have 3 spots. There's 16 for the first, then there's 15, then there's 14. If we multiply that together, we get 3,360 ways. We solved this using a permutation because order mattered, and we took these 3 pieces and multiplied those chances. The others didn't matter. We just want first, second, and third place. Okay? So this represents all the possible ways of doing something when the order matters. So taking 16 times 15 times 14 isn't too hard. But what if we had 16 things and we wanted to do first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and not all the way to 16, but just somewhere in between? That would take way too long to put in our calculator. So we can use the shortcut on our calculator or Desmos. If you hit Desmos and you hit the functions and go all the way down, but you're not going to be able to use Desmos on your test. So we're going to use that calculator again. So you hit math and you go over to prob and you're going to use the number 2. Okay. You have to put a number in first. So we had 16 things and we wanted to choose the 3 first, second, and third place. So if we do that, we get 3,360 and we don't have to write the 16 times 15 times 30. So you can use either one of those. Okay. What this thing does is it takes n factorial and it divides it by, like yesterday when we were doing the pieces that we didn't care about what was happening to them, or the word when the letters repeated and we couldn't tell the difference. It's kind of doing that. So it's taking n factorial and then dividing by n minus r factorial, or we're going to get rid of, so if we looked at the problem we just did, it really did 16 divide by 16 minus 3, or 13 factorial. And if you think about what that does, it's going to take 13 factorial, if I write that out, and a 14 in there, and the 13 factorial, and it's going to take all of those and reduce them all the way down, so you're only left with those 3. Okay, so remember that the n is the total number of objects, and r is the number of objects being chosen or taken. So we want, out of the 16, we wanted 3. Okay. There are 5 finalists in the Mr. Panther pageant. In how many ways can the judges choose a winner and a runner-up? So if you have 5 and you want to choose 2, we can put that in the calculator. But really, we have 5 ways of picking the first one and 4 ways of picking the next one. There would be 20 ways. So doing this one by hand isn't too hard, but just to show in the calculator one more time, math. I'm going to do this first. I'm going to hit 2, then choose math. Clear. 5. There were 5 people. Math. Go over to probability, then choose the permutation, and then I can go, this calculator won't do it. Your calculator makes you put the 5 in first, not, I guess this one doesn't do that. Oh my goodness. So we have to hit math and go over to probability. Okay, now it's just being rotten. Okay, 5. Clear. Not at my best tonight. We're going to choose number 2. So now we can put 5 in there, and we can go on the other side and choose 2. When I put that in, it does 20. Okay? So you can do it either way, by hand or by the formula. Okay? All right, let's look at this next one. So a combination lock uses permutations, which means the order matters. Okay, that's going to become important in a minute. If the order matters, even though it carries the name combination, order definitely matters. The lockers in the hallway have 49 numbers you can dial. Each combination contains 3 numbers. How many combinations are possible? Well, there's 49 for the first one, then 48 for the second one, and 47 for the next one, because we have to take one number away each time because they're not allowed to repeat. So we can either put all that in our calculator, or take this times this, or we can go 49, permutation, we want to choose 3. So either way you do that, when you put that in your calculator, you get 110,544 ways. Okay? So take a second and put that in your calculator. Make sure that you're getting that, whether you want to multiply it this direction or you want to do this. I would kind of try both. All right, welcome back. Okay, you put a playlist that has 8 songs on your phone. You set your phone to play the songs at random. Your phone plays all 8 songs without repeating any song. So if they don't repeat, that means that the order mattered. When its order matters, it's a permutation. How many total ways can the 8 songs be played? So we have 8, and then 7, and then 6. Really, that one's going to go all the way down. All the way, multiply each one. So that's really just 8 factorial. So you could use that factorial button, or you could choose permutation 8, choose 8. Any of those ways that you want to type that in, and you're going to get 40,320. Make sure that you're getting that one of those ways and you know how to do that. Okay? All right. So pause this and practice these 4 problems at your table, and then turn this back on. Welcome back. Okay, so let's look at what answers we should have gotten here. There are 16 teams in the state basketball tournament. How many ways can the first, second, third, and fourth place team places be made? So if you use permutations, you have 16, permutation 4, or you had a 16, then a 15, then a 14, then a 13. Because you can pick first place 16 ways, but then you only have 15 ways for second, and 14 ways for third, and 13 ways for fourth. So whichever way you did this, you should have gotten 43,680 ways. There are 12 girls on the varsity softball team. How many different ways can the coach make a batting order if 9 girls bat? So you have 12, permutation 9, because this one is kind of a pain if you went 12 and then 11, and you had to count down until there were 9 spots. That one's not very much, that's not nice to write. We want to use this one. So when you put this one in, there's a lot. 79,833,600. So lots of different ways. How many possible 6-digit zip codes begin with the number 6 and end with the number 8? So we did this on our last worksheet. We had 5 places. There's only one way to pick this one because it has to be 6. There's only one way to pick this one. It has to be 8. But then we don't care if those numbers repeat in the middle. It didn't say they couldn't. So then there's 10 ways, 10, and 10 to pick each of those. So 1 times 10 times 10 times 10 gives us 1,000 ways. Okay? All right. Suppose that the top 4 basketball teams, we don't need the E in there, top 4 basketball teams from above do not get first, second, third, and fourth place, but just the honor of being in the top 4. How many different ways can the honors be given? How does this change the problem? So a permutation, the password to the garage is 4725. The orders of the number are important. This one won't work. This one won't work. It has to be exact. But in a combination, my fruit salad is a combination of apples, grapes, and bananas. We don't care what order they go in. We just care that there are some in there. Okay? If the order does matter, it's a permutation. If the order does not matter, it's a combination. Okay? So let's look at an example. We have 4 letters in a hat, A, B, C, D. How many possible ways can 3 letters be picked if the order doesn't matter? So if the order doesn't matter, then you have the first letter, you have an A, then you can have B, C, D, and then from there you would have C, or you could have C. Here I can have C, D. I could have B, or D. I've already used D with both. Oops, I didn't put that one there. I would have BC. So I've already used D with both of those combinations. This only gives me 1, 2, 3, and then B, C, D without an A. That gives me 4 combinations if the order doesn't matter. If the order does matter, I have 4 choices, then 3 choices, then 2 choices. So if I multiply those together, I get 24. Or I would have for permutation, choose 3. Okay, either one of those would work. So they are very different. They mean different things. Okay, so we have to decide, does the order matter? Let's look at this next one. Picking a team of 3 people from a group of 12. Did it say how those 3 people were picked? Nope. We don't care if it's 1, 2, 3, 3, 1, 2, as long as you have a certain 3 people in that group. So this one is a combination. Picking a pitcher, a catcher, and a water boy from a group of 12. Those matter. They have special names. So this one's a permutation. The order mattered. Listing your 3 favorite desserts in order from a menu of 10. So if there's order, then it's a permutation. Choosing 3 desserts from a menu of 10. I don't care what 3 desserts. I don't care what order you choose them. So this one would be a combination. Okay? It matters because the 2 formulas are very different. We have a shortcut in our calculator and Desmos. So if you were at some point using Desmos, like on the ACT, if you hit that function button, you can go down and you can find these. But we're going to use our calculator. So if I go math and I go over to probability, I not only have the factorial as number 4, number 2 is NPR, I have number 3 NCR. So that one's the combination. Okay, so we would be able to use that. I don't want to use them at the same time though. So we will put that in there and we will go grab a problem that we can use it for. Except for I keep using the wrong one. What am I hitting? Oh, number 3. There we go. Okay, so we have it ready. Let's go grab a problem. First of all, I should probably tell you what the combination thing means and what it does. So you still have to choose a set number of objects. But then, just like our lettering, we don't care about the repeats. We don't care about that order. So you have to divide by how many things you're choosing, because we don't care about the order of those 3 things. We just want those 3 things. And then this over here is this takes out the repeats of those. So if you have 3, 1, 2, 2, 1, 3, this takes out the repeats of all the different types of combinations. Okay? So N is the total, again, number of objects, and R is the number of our objects being taken or chosen. Okay? Only one O in chosen. Okay, so now let's look at some problems. First off, you have to choose, does order matter or does the order not matter, so that you know which formula to use. The math department has 21 teachers altogether. The department chair has to select 5 members to be on part of the algebra team. How many different ways can the teachers be chosen? He didn't say he cares which 5 teachers are chosen, just that there are 5. So the order doesn't matter. When the order doesn't matter, then we use the C. Okay? We don't want to write that formula every time. We're just going to make the calculator do this for us. So we have 21 and we want to choose 5. So we go back here. We have that set up. We have 21, choose 5. And remember, your real graphing calculators that does this one on the iPad is a little different. Yours might want you to put in 21, then hit the button, then you can put a 5. Okay, it might not just do those little X's or the little boxes. So we get 20,349. So we have 20,349 ways. Every Friday night, your family orders pizza. This Friday, it's your turn to pick the toppings. There are 12 toppings offered, and you're allowed to pick 3. Does it matter what order you put them on a pizza? Nope. So since the order doesn't matter, it's a combination. So there are 12. You only get to pick 3. So when you put that into your calculator, try it. You should get 220. If you wanted to do it the long way, it would be 12 factorial over 3 factorial times, we don't care what those other 9 toppings are doing because they're not going on our pizza. So that's the 12 minus 3 factorial, or 9. So then you would have to go 12 times 11 times 10 times 9 factorial. That was a times. And then you have 3 times 2 times 1 times 9 factorial. I leave the 9 factorial because those 2 would cancel out the rest of the way. And then you could reduce. See, this is a huge pain. Why would you do this? This is 6 with 12. That would leave 2. So you would have 2 times 11 times 10. Blech. We don't want to do that by hand, but you would get 220. Use this button in your calculator. Okay? All right, next. The softball team has 12 players. How many ways can the coach choose 9 players that will start the game? He didn't say it's a batting order. He just said 9 to start the game. So again, we have the combination because our order doesn't matter. Does not matter. You don't have to write that. I'm just showing why I'm picking which one I am. So we have 12 players. We want 9 of them to start our game. So when we do this one also ends up as 220. Sometimes it's kind of weird like that. You had this 3 and you had 9. Doesn't matter which order you multiply. So those 2 kind of came out together. All right, number 7. From the same 12 players, in how many ways can the coach write the batting order? So order means that we have the order matters. So now we have to do a permutation. So we have 12, choose 9. This is very different, and this is that number we had above, 79,833,600. Okay. All right. So a lot of notes there. Try your best, and I will finally be back on Monday. You guys have the rest of the time to work on this. Make sure homework assignments 1 and 2 are done. The answer keys are in Schoology, but make sure you understand them because you have a test in less than a week and a half. Okay? Talk to you guys soon. Bye.